investing your time with us on a Saturday afternoon. Myself, architect Vibhuti Joshi, assistant professor at Code VGU, and I am the anchor for today's session. So, I'll be introducing the panelist for today's session, and it is with a great pleasure that Code VGU is given a chance to be associated with the Jain Memorial Trust, and they are doing a great work by organizing this Harit Prem Bharat Mahotsav, and the sessions which these guys have come up with are really trending, new, and important for us to actually know more about. So it is with a great pleasure that I welcome all of you and our honorable keynote speaker, Mr. Gaurav Vasudev, who will be the panel session, and the topic will be role of solar hybrid air conditioning in sustainable environment. Then I would like to welcome Mr. Dharmendra Rathod, President Ashray Indian Chapter to 2020 to 21. He is the founder and CEO of Automotion Ecotech Private Limited. He has done his education from IIMA Ahmedabad Management and BE Mechanical Technical. He is an entrepreneur, and with Mechanical Engineering and Management certification from IIMA, he has more than 15 years of experience in various fields and positions within building segment. He worked with Danfoss on various levels before he started his entrepreneur journey in 2012 with a trading company, Astitwa Engineers, in the field of HVAC and energy facility solutions subsequently. He was also co-promoter and COO of Elgreen Ecotech Private Limited before founding the automation. He is also currently the Prem Jain Memorial Trust Board of Governor. Rest, we have our college representative from Code VGU, Dr. Shweta Chaudhary. He is the Center Head Code of Faculty of Architecture and Planning, academician and practicing architect for around 15 years now. She strongly believes in experimenting and working towards pedagogies for the design curriculum and the new generation professionals and students. She herself is a PhD in energy efficiency assessment of buildings with keen interest in understanding and re-establishing history through scientific experimentation. She indeed is the strength of pillar for the department, and via her we get these opportunities to get associated with NGOs like Prem Jain Memorial Trust. Thank you so much, ma'am, and thank you so much, Prem Jain Memorial Trust, for trusting us and giving us an opportunity to engage our university with you guys so that our students can get a fair perspective and a more knowledge sharing from the eminent speaker. Then I would like to introduce the speaker for today, Mr. Gaurav Vasudev. He is the managing director at the GAPS Group. He is leading a group of companies, GAPS, GEPS, and LTI India, which drives engineering services and specialized products in HVAC and indoor air quality. He has developed his 22 plus years of commercial and business experience in HVAC industry, which covers ventilation, indoor air quality, fan engineering and manufacturing, smoke management, acoustic products, new product development, and energy efficiency solutions, especially solar hybrid air conditioning, external sun protection. He is also ISHRE certified professional for clean room applications. In addition to his work, he is currently serving as Regional North Director, North 18 ISHRE India. In past, he served the positions as President Delhi Chapter of ISHRE 2017 to 2018, as Country Head India 2012 to 2015, MD of System Air Operations in India. He is an active and recognized member of ISHRE, ASHRE, SIE, FSAI, and ISLE. He is actively involved with the student fraternity, and through his knowledge and motivational talks, he has given career direction to many students. And he is indeed a wonderful speaker, and I'm sure students will enjoy today's session a lot. So I would request Mr. Dharmendra Rathod sir to say few words to the students and our audience. Thank you. Hello. Yatendra sir?
I think he's on mute.
Yatendra sir?
Yeah, I'm here. He's in.
Am I
I think.
audible?
Yeah, he's coming.
Hello.
Yeah, he's coming on board. Yeah.
Yeah. Okay. So our college representative, Dr. Shweta Chaudhary, is also there with us. So
Namaskar, sir.
I would request her to introduce her and address the panelists and students. Off to you, ma'am.
Thank you, Vibhuti ma'am. Thanks a lot. And big thanks to the Association Harit Prem Bharat for involving us into this noble cause. VGU is really delighted to be a part of this endeavor. And we assure Harit Prem Bharat to be that VGU would always be a part of this kind of an initiative. We will definitely take it forward amongst our students and faculties and take this initiative of yours to a larger volume. And I congratulate Gaurav sir and Dharmendra sir for taking this initiative of spreading this kind of information amongst the youth, because definitely with this thought, we would be making this world a better place to live. Surely Earth would become better if we keep on thinking about such things. Technology and environment bred together will lead to solar hybrid air conditioning, I'm sure. And I'm personally looking forward to Sir's session today, where he would enlighten us more on this aspect. And definitely the students from architecture and technology and design departments who have joined in will be getting some new perspective to how technology can be used for the benefit of environment. So I am a personally I'm interested into it, sir. Thanks for making it so interesting. I mean, the day when I was told it is solar hybrid technology intervention, I mean, I was interested in knowing that how technology can be good for environment, because we've been talking to students and even at home, the technology has always been an issue with the environment and is not really green. So utilizing for a good cause would definitely be something that we would like to be a part of. Also, I extend a big thanks to Dharmendra sir for giving us this opportunity, and Prem Jain Memorial Trust for being a part of this kind of an initiative and making VGU feel blessed. Gaurav sir, so I mean, being a part of ASHRAE, I'm sure you must have achieved a lot of accomplishments and you must have taken a lot of challenges. You have a new challenge put up to you through VGU today, that please honor us and enlighten our students, initiate and motivate them to do something great with their initiations of technology development into environment. Thank you for your support and time, and VGU is obliged and grateful to all of you for the opportunities that you provide. Thank you, sirs. Off to Vibhuti, ma'am.
Thank you so much, ma'am. I would request Dharmendra sir to address the students and the panelists, and then we can start with the session.
Thank you, Professor Vibhuti. Thank you so much. Thanks, Professor Shweta ji. Special thanks to Vivekananda Global University for tying up with PJMT and being part of Harit Prem Bharat Mahotsav. PJMT also been involved in 12 technical insightful session which are being organized to address the importance and the need of the sustainability in built environment. We are especially curated for Harit Prem Bharat Mahotsav 2021 to spread awareness amongst future generations about a greener and the better way of life. Green Talk are a special series on dialogues led by green champions and stalwarts who walk the green in their daily lives and will engage with architect and engineering students, young working professionals to guide and mentor the path of better and greener path and future tomorrow. I I really thank you for tying up with us, and we look forward to do much more with you in future. Like you can see, there is a Vivekanand behind me also. So, you know, so I really like your name, Global Vivekanand, because Vivekanand was, in my little knowledge, he was the first Indian who can actually be considered as a real global personality. So thank you so much, and best of luck for the session, Gaurav. Good thing that we have planned this. Thank you very much once again.
Thank you, sir, for your kind words, and thank you so much for introducing this series so that we, as institutes, can get associated with NGOs like you who are doing a great job, and it could benefit the students at a large scale. Thank you, sir.
Thank you.
Now, I would like to request Mr. Gaurav, sir, to start the session.
Thank you.
Off to you, sir. Yeah.
It's a great honor to be part of this this event today. And personally, I worked under Dr. Jan at many forums at Ishre, and learned a lot from him in person, because he is the one who has given kind of a birth to Ishre. He was the stalwart who started, and even in Ishre we have K to 12 activities where we, if I think in 1984, he put up a vision that we should start giving a knowledge to our students' fraternity as much as we can, because they are the future. The age we are in, I think we have already crossed half of our age, and whatever we are living with, we can actually make it better for the future generation. And that is how we are all connected to this particular event. And I really appreciate Code VGU giving us this opportunity, giving me this opportunity to share the knowledge with students. This is something very new, unique, which has come up, probably has been used in other part of world more aggressively than what we have still not started using. This is kind of application which makes our air conditioning merging with solar renewable energy, and saving a lot of demand on power. So I'm just sharing my screen now. So Yatindra, can I share my screen, please?
Yeah, please go ahead, sir.
Thank you so much. Okay.
While sir is sharing the screen, I would request all the participants to use the chat box and the Q&A dialog box, which is there at the bottom down. So you can ask questions meanwhile the session is going on. And at the end, we will cater to all the questions asked by your side. It would be lovely to have an interactive session with all of you. Thank you so much. Yes, sir.
Okay, so my screen is visible to all of you?
Yes, sir. Yes, sir.
Yes.
All right. So thank you so much. I think it was very well introduced by Vibhuti ma'am. So thank you, Vibhuti ma'am. Going ahead, as you know, my name is Gaurav Vasudev, and I've been working in Ishre for a long time. And today I've been given a task to speak on solar hybrid air conditioning and how it is gelled up with sustainable environment, and why do we need it. So let's go. What is sustainability? I think in architecture syllabus we all speak about sustainable products or buildings or everything what we need to create for future generations. So sustainability, to everybody's knowledge, is something what we can what we can use without losing the total demand for future generations. So we should not actually waste the nature or the material or the products available with us for future generation. I heard, or I saw a very good video or a kind of advertisement made by Tata sometimes back, where what they did, they asked some adults of 30 plus to come into a room, and they have given a lot of colors to make something on a paper as a drawing or something. And they have been told that, okay, you should use the resources very thoughtfully, so that next group which is going to come in, they need to use the rest of it. And then the next group which has came in, there was the kids from schools, from nursery to second class or third class, and they have been given the same task to create something on the paper with the available resources, but they have left out by the generation before. And you will imagine the guys of adult age, they made a beautiful green, colorful drawings and all. And the moment the kids have come, the all colors was over, and they were just making kind of a pictures with black or gray colors. So this is very much related to sustainability, that we need to prevent our resources so that the next generations can use them. Okay, so this is one of the application, or what we think about the sustainability. Okay, so going ahead, why it is important? Of course, we are all are living creatures. We need to breathe. We need to eat. We need to survive with all those natural resources. Um, Doing that, if we don't take care of sustainability into it, we will go out of natural resources, and that will create a toxic environment, which is not good for anyone to sustain or to live in a better environment. How can we do it? There are very wide applications there. I can give a very generic examples. Solar energy, which has been very widely used today into our country, and believe me, we are very fortunate that we get about 200 plus days of sun in our country. Whereas if you go to Western countries, they are living up with only 115 days of sun over the year. So we have been given grace of God to have good solar energy, which we can convert into generating power, or in hybrid applications, or some other heating applications by solar. Wind energy, again, we have been quite fortunate in our country to have good wind powers, good wind energy. If we go up into Himalayas, or we go down to Kanyakumari, we have a good wind velocity over the year, which can be converted into mechanical energy or electrical energy one way or another. Again, hydropower is another um, known example of renewable energy, where we can store the rainwater and use it as a dams, and creating electricity with that particular hydropower. One example, this is, I think, when we are in North, we all have an access to Chandigarh, and this is Chandigarh Sukhna Lake. You can see here, there's one wind turbine which has been installed long ago to create the energy for this particular lake's requirement. So one turbine is actually taking care of all um, power requirement of Sukhna Lake. So one example, another one which is solar. You can see a solar PV plant on a parking station. You can see this kind of parking station in Badapur Metro and on Faridabad line. So there are a couple of stations who actually come up with solar PV panels or solar PV plant, which is not only taking care of their local energy requirements of the station, it is also adding or giving back something to on-grid, or selling it to Delhi power plants, Delhi power requirement. All right, so two examples. I did not add anything of hydro, because dams are very commonly used and known to us from our childhoods. So there is a difference between green and sustainability. Of course, they are similar. They go hand in hand. but it is often confusing when we say that we go green and we are sustainable. Going green would be a very small niche part, very small part of sustainability altogether. So green is majorly spoken about when we talk about a product in general. So one product can be a green product, but sustainability is multiple green products into it. But just imagine one thing: if we produce a green product and we spend a lot of energy to bring that green product from other country to our country, or from our country to another country, it will not be a green product, because we are spending so much of a fuel energy to take that product from one stage to one country to another country. So that will not be a sustainable product, whether it's a green product. So green means a product which is made out of reused items or reusable materials. But sustainable is to keep it there, used locally. So that's we call vocal for local. So whatever is produced green locally is more useful for sustainability, rather than producing it outside and bringing it to our country. That will not be considered as sustainable product in that condition. All right. So let's create a sustainable environment. How can we contribute today to sustainable environment? And as I am a HVAC person, I've been working into this industry from last 22 years, or more than 22 years. So I will be focusing only on HVAC side, where we can um, do some innovative ideas or technologies to save some energy. Okay, so how can we do that? The first thing which comes to my mind is energy, which we consume, which we use into our buildings. And this is something which I picked up from good information from US and other local available literatures. The major source of global demand energy going to buildings, we all know that today. Maybe it's our offices or our houses. In last year, 39% or more than 39% of energy used into HVAC. So you can imagine, if we are producing 100 megawatt, we are using 39 or 39 plus megawatt into HVAC only. Okay, so these high consumption give a byproduct of greenhouse gases. I'm talking about only Delhi now. So you imagine, in 2000 and in year 2000, we had a power consumption of 155 kilowatt hour per month, which has gone up to 2,260 kilowatt hours monthly in 16-17. And now you go down, you see the usage, 5,298 megawatt over the year in 2019, which is almost three times than what we were using in 2000. So the demand is increasing every day. We are earlier, air conditioning was just luxury for some people, but today it is a necessity with us. Every household is having air conditioning systems available, and moreover, with the new technologies, it is for heating and cooling both applications. So energy demand is going to increase every day with the new technologies setting in. They are getting cheaper, affordable for everybody to be installed in their houses. I'm not talking about only commercial offices. I'm talking about complete application, residential and commercial both. So energy demand is going to increase. What will happen with that? We need to put up more stations. There's one of the stations in Delhi we have that will add up to excessive carbon emission, and that carbon emission will take us to global warming. We all know about global warming. We all speak about global warming. And how does it happen? When we start emitting a lot of carbon dioxide or carbon footprint, that will increase our Earth's temperature. Every year it is increasing. There is a lot of lot of discussions going globally on this, and people are looking into how we can make a sustainable globe or sustainable environment in that. So what will happen with the global warming? The global warming is going to create a lot of floods. This is a picture from Mumbai a couple of years back. Tsunami, that's also an effect of global warming, uh, which has come up a few years back. Okay, then if I go further, forest fires, that's also part of global warming, because um, our forests are getting into kind of a fire situation because of high temperatures. When the trees are rubbing with each other, they can create a fire in a dry environment. And the good examples you might have heard in last year, it was in America as well as in Australia. So there was a lot of consequences which has come up with the global warming thing. So everybody is speaking about Kyoto Protocol has started long back, which was intended, which was speaking about how we can reduce the carbon dioxide emission on this earth. Carbon dioxide in general is very much required for our globe, because that gives life to trees, and it is also one of the important element which is causing a kind of rains and all that. So it's a very important component, but the moment anything which is excessive, it keeps on troubling our natural resources, so natural environment. So Kyoto Protocol has speaking about carbon emission to be reduced one way or another. So in HVAC, there's a new technologies, new ideas, some solutions have come up, new technologies for chillers, kind of compressor which does not have a bearings. So it's a magnetic compressor. So the moment we reduce the friction into our compressors, we'll have a better efficiency of those compressors. Then you might have heard about VRV and VRF. These are slightly advanced technology from our split air conditioners or window air conditioners. What will happen that these particular technologies will use the compressor power only when it is required. So it's called a demand control application as well. And then of course, hybrid air conditioning, which we are going to speak today. Green products, of course, a lot of green products has been introduced in India, and they are doing good. And uh, doing all these things together will give you an opportunity to rate the buildings under many different third parties, like lead applications. You can have a platinum building, a green platinum building, and all that, which was also started in India by Dr. Jain. Renewable energy use, wherever possible, we are now looking at our option to use solar energy, hydropower, wind energy, and of course solar hybrid applications. Solar hybrid is not only used in air conditioning, but also it has been used for heating up water in hotels or in houses up in north, where the temperatures are really low, but they are fortunate to have sun during these minus temperatures as well. So is in Delhi. You might have seen a lot of application where you can have a solar heating plant on top of a building. All right, so let's start speaking about the technology which is called hybrid. It is not PV, but it is a solar vacuum or thermodynamics collection system. So if I need to put up an example, for a 9-ton cooling capacity chiller or VRF or VRV, we need to have 30 to 40 solar PV panels. And whereas one thermodynamics collection system can save equivalent energy. So you can see the footprint of 40 PV panels and footprint of a one small solar panel, hybrid panel. Okay, how does it work? The most important thing, where do we consume the maximum energy into an air conditioning system? and it is into our compressor. Compressor can be of any type. It can be inverter, super DC, hyper DC, staged, digital scroll, uh, and 80% of total consumption of air conditioning system is into the compressors generally. Okay, so let's speak about some different kind of applications. So inverter type, digital scroll, multi-stage systems, how does it work? In general conception, in general thing, when the load is very, um, let's say optimal loads, then your compressor is working only 30% of total capacity. The moment it's getting hotter, to provide that kind of cooling, the compressor need to run to the full capacity, to the maximum capacity. So the hotter it gets, harder for the compressor to match up those requirements. This can be DC, super DC, this can be digital scroll, anything which is modulating compressor, which we call a modulating compressors. Then we come down to our stage system. In stage system, we need to, let's say we have a chiller which need 450-ton capacity to reach. So there will be 3 compressors of 150 ton each. So when the requirement is going to grow, they are going to come up and start running. So in that particular condition, when again, the moment the loads are getting higher, all 3 need to work. So you can imagine every compressor is consuming a lot of energy in that case. But what will happen if we come up with a solution with the hybrid thermodynamics collection system? We can really run our compressors on optimal conditions at all times. This is the only way you can save energy. This is one of the best way of saving energy using the solar power. So what it's happening is the refrigerant, which I'll explain in a couple of more slides. I think that will be better. How does it work? This is getting a little technical in this couple of slides. So if you have a question, please start writing into the chat boxes, and I'll try and answer after the presentation. So solar hybrid panel or thermodynamics collection system will be installed post compressor and before condensing unit. Okay. This can be used for both heating and cooling. It is equally effective. And I can tell you from the experience what we had in India, abroad as well, but in India, it can give you up to 49% of saving during summer. And on average, a year, it can give you 30% plus energy saving on any modulating compressor, air cooled. Okay, so let's speak about the technology now. How does it work? What exactly does this mean? We have picked up animation. I'm sure you all can see the animation which is going on. Vibhuti, can you confirm that if you can see the animation?
Yes, sir.
Okay,
yes,
great.
It's
Thank you so much. Thank you so much.
Yeah.
So in general condition, there are 5 important components of air conditioning system. One, which is running on your left hand side, that's the compressor. Second one is the condenser, expansion valve, and evaporator, and the complete circuit which has been closed by copper tubes. Okay, so the copper tubes are connecting all these 4 important parts of air conditioning together in it. Just to give you an example, we might have seen a refrigerator system at your houses. Purane wale jo hote the, they had a kind of a black tubes at the back. Those were the condensing unit tubes. So those were the condensers. And jahan pe hum barf jamate the, that was our evaporator. That is the cooling place what we used to have. and there was a black box under that particular black tubes at the back. That was a compressor. So compressor, expansion valve, condenser, and evaporator is part of system. So in normal condition, when the load goes up, evaporator speaks to compressors and to increase the load that we need to pick up for more heat from that area. So this heat from refrigerator or cold chain or from any other applications, including your commercial air conditioning. So what will happen? We will add one thermodynamics collection system. So now what will happen? Earlier we were able to increase. Now in technical terms, post compressor, we increase two parameters of this particular refrigerant. One is the temperature, second is the pressure, which is very much required to complete the thermodynamics application or this air conditioning application. So every condenser, every part has been designed based on delta T. So delta T is that I have 40-degree temperature outside, and my compressor is releasing the hot pressurized gas at 55 degrees. So the delta T between 55 and 40 is 15 degrees. So condenser is going to be based on that 15-degree design. So what will happen? The moment we add a panel, we are increasing that 15 degrees to 45 degrees. So your delta become higher. Okay, so delta becomes higher. So 40 versus 45, the total temperature in condenser is going as 85 degrees, which is far more higher than what the condenser has been designed for. So what will happen? There is an example, there is a thermodynamics principle. अगर हम पानी को बहुत ज़्यादा boil करते हैं या boil करते हैं, and then we go out in minus degrees, let's say -2, -3, and we throw the water in air, it will be frozen immediately. And if you want to do that at your houses, you just boil the water and keep it in your refrigerator. It'll be ice in no seconds. So that is how the thermodynamics works. The moment you have a better delta T, you will have better results altogether. So this pressurized gas at 85 degrees, when it goes down to condenser at a higher velocity, higher kinetic energy, it will flood up your condensing system. The moment you have a more gas in the condenser, it will be converted into liquid. Okay, so it becomes high pressure liquid now. That will pass through the expansion valve. Expansion valve will send it to the evaporator. In evaporator, it will pick up the heat from the environment, and again it will send back to the compressor. So now what will happen? Once this circle is complete, once or twice, there'll be a communication between electronics, through electronics, between evaporator and compressor. What compressors are going to understand? Okay, now there is enough of chilling in the evaporator. We need to shut down ourselves. The moment you shut down two compressors, the only one compressor is working at the maximum consumption, again giving you the total load conditions. So nothing, there's no mechanical part into it, there's no electronic part into it. This particular system is risk-free. Retrofit application is possible. So even if we see today that one particular application or one particular project who have air-cooled VRV or VRF or air-cooled chillers, this can be implemented on those conditions as well. So this is not just for the new projects. This kind of technology can be used with retrofit applications as well. And then it comes to when you start speaking about this, people will ask you the ROI. The ROI is within 3 years, whereas the product life is for 20 years. So 20 years versus 3 years, and you have seen the demand increasing in electricity. Electricity prices are going up every day. It will keep on increasing. for next 20 years. And that is how using a thermodynamic collection system, you can reduce the power consumption in compressors, which will help you to further reduce down your energy bill from a very best design to the new technology. Okay, so let's go ahead with this. Any questions so far in this one? If anybody have, can I see the chat box, or can somebody help me with these questions?
Hello. So,
Yeah,
as of now, we
no
don't have any
questions.
questions, but
Okay,
I would
great. So
request the attendees to ask questions so that we
wherever,
have a
whatever
more
kind
of,
of questions you
yeah,
have, yeah.
more of interactive session rather than giving it a one-way feeling to the speaker.
The
Yeah,
only thing is when you're not face to face, it does
yeah,
not become that interactive. But I'm trying that if this can work out to be, more interactive session. Let's see. Let's see. All right.
sure,
So
sir.
testing data. Again, every product have its own testing data. You can see the red lines and you can see the blue lines. Red lines are when we are not using a hybrid converter into it or solar inverter into it. What will happen? You will have a spiking. The moment you have a lunchtime, let's say I'm giving an example of a canteen. Now there's a lunchtime. Again, the peak load is increasing. The heat load is coming in. Your compressor will start working on a very high load. Whereas the moment it has gone down to the half, some people have left already, it will come down. And then some another 10 people added up, it is going to increase your power consumption on compressor. And of course, it is going to increase the compressor speed and all of the things. Whereas the moment you put up a hybrid panel into it, what will happen? It is trying to keep the constant wave. Once it is gone up, uh, now the compressor has started working on a higher level because it was not syncing, it was not communicated to the evaporator at that point of time. But after a couple of seconds or minutes, it will start communicating better, start picking up a lot of heat from that thermodynamic system, and again making a compressor to work down on a very optimal conditions. uh, how does it help in addition to energy saving? It is helping in terms of saving the compressor from the mechanical damages. The moment something is working in mechanical language, it will have a kind of a resistance and it will have wear and tear. Whereas the continuous spiking will have more wear and tear rather than having a constant speed on a compressor. So this is also one of the additional benefit which comes out or which comes as a package with hybrid conditioning. And this is how you can see the energy loads. One of the customers in South Africa has given this particular data to the company who's producing this. And then how we can see this is working, it's very easy. And if we have any mechanical engineer, he in this particular audiences today, he will have a question that, okay, if I'm picking up a temperature, I will definitely pick up a pressure also, and that is not healthy for the system. So for those students, you can see there is a temperature rise. If you can see my cursor, from 28 degrees C to 58 degrees C. This is a panel pickup temperature, inlet and outlet. Whereas if you can see here, your inlet temperature was pressure was 16.301 bar. Picked up pressure was zero point zero 0.04 bar, which is not affecting your copper tubing, which is not affecting the complete system. So by picking a very small pressure against 30 degrees of temperature, um, this system can be applicable for any kind of use. Uh, also, the reason why we are not picking up a pressure in this technology, because it's an open loop system. It is not closed. It does have a bypass wall. The moment it goes up certain condition, it can bypass and become the normal. And this need a constant, constant solar light. It does not work like a PV, that even if you have a clouds, this will give you some power or energy. This need a complete clear sunlight. And believe me, when you have a better sunlight, you have a higher loads inside. If you don't have a sunlight properly, your loads are lesser and your system is capable to work on a optimal condition during that time only. All right. Some of the application versus saving, different applications have a different kind of a saving. So it can be 12 months ROI, it can be 15, 18 months, 32 months based on the usage. This technology is only suitable for application where we are using the air conditioning system more than 8 hours, 8 to 10 hours. Let's say I'm talking about a commercial building where you have your VRF or air cooled chiller working there, which is from morning 7 to evening 7, 12 hours, 12 hours in summer season. There, this kind of application is worth installing because you will have a very low ROI. This technology is not good for residences where you are using the air conditioning system only at night when you go back home and you have nighttime of application of air conditioning. It will not work there. That's not a viable solution for those applications because at night this system will be bypassed because you don't have any sun, and this will not help you to save any kind of energy here. Okay, so Indian installation, I was talking about this. So this installation is in Baroda. It's a transformer manufacturing company. You can see here there is an outdoor unit which we call outdoor unit for any kind. It's a Blue Star make with 22 HP in capacity. It was serving to a quality inspection area of that particular factory. So what we did, we installed these panels there. We installed an IoT meter. Um, just in this panel, there was an IoT meter which is communicating through Wi-Fi technology, and a bypass wall has been installed. So day one in February 2018, I believe, yeah, 2019, February 2019, the system has been installed. So day one, they ran for 8 to 10 hours. They noted down how much power they have consumed in that particular condition. Day two, they open up the thermodynamic system. After opening up thermodynamic system, they have observed in February 3rd, they had 28% of saving. Similarly, they followed this principle for 6 months, and in July, they have come up with a number which was 49% of energy saving on day-to-day use. So the load was constant, hours were constant, unit was constant. The only difference was thermodynamic system in and thermodynamic system out. So they observed that they had about 47, 48% of saving in July. With that, they came to conclusion that we want to install these technology to 450-ton chiller, what they are having in their plants, because the complete plant was air conditioned and it was working 24/7. Okay, some global installations. This will give you a kind of uh, eye-opening to installation outside India. There are total in world, this particular technology have more than 20,000 application as on today in last 3 to 4 years of its invention. Okay, so Fast and Furious, we all have seen Fast and Furious movie. When these kind of movie has been produced, you can see in the background of these actors, you can see eco legs. These are their containers which travel with them as a vanity van. to wherever they go for a shooting. Okay, so this van, this particular person who was renting it out to the directors and to industry, uh, has a complaint that he is not able to make these particular containers off grid. So they came up and met with one of the dealers of this particular product, and they come up with a solution. So what they did, they put up one solar thermodynamics collection system with PV panels into it, and they were able to make it total off-grid solution. So wherever they go, they charge the batteries with PV panels, and they run the air conditioning system through thermodynamic panel. So there were some cloudy days before and after also. So the fuel what they have consumed in 120 days of production was somewhere about $150,000. Okay, before the solar thermodynamics panel have been installed. But post that, what they have consumed was just $1,500 on $10,000 only for this particular application. So wherever he was using 1,50,000 on diesel consumption to run the DG sets to keep it energized all the time, he was spending only $10,000 for that particular time when there was a cloud and he was not able to charge or run the air conditioning system directly through solar PV panel. So some more applications there can be installed over the condensing unit. So you can see the condensing unit below, and it can be installed, and it can be installed with any make. There's no restriction to any make. So you can have all good brands, Daikin, Carrier, Toshiba, Mitsubishi, Gree, any name, and this is compatible to those solutions, to those applications. And moreover, you might have seen here, if I can go to slide before, it is a flat application. You need not to, as an architect, it's very important that you are also looking at parapet or your facade, that this kind of product should not be visible from top. So this can be installed horizontally. It can be installed at an angle of 45 degrees or 30 degrees or 35 degrees, wherever you can get the most sun in any direction. It can be on wall, vertical on wall. It can be on roof. It can be on flat. You can see some more examples. Okay, they had a space, so they put it up here. There's again on the condensing unit with the Carrier make. This is in South Africa. I'm sure you all know that South Africa is running out of water for the last couple of years. So all their air conditioning is air cooled at this moment. So they are using air cooled compressors, air cooled condensers, and that is how this has been achieved. Okay, process plants, and this is at Media Global Innovation Center. So Toshiba, Carrier, Media, all of them, they are using this technology at their innovation center in Taiwan, I believe. Okay, so this another application. You can see that there the architect does not want that we should lose the glance of the roof. So they have installed all the panel at 0 degrees horizontally, and they are still able to achieve it. Another application, horizontal application. So another examples, and this is across the world, is not from one place. I picked up a good number of installation across the world, which has been speaking about this technology. And power station, this was for heating. This was the heating application in a power plant. Another good example, or let's say one of the biggest applications so far in the world, where they have installed about 54 panels for serving 3 different chillers. One chiller is always on demand application or something. So that's something which is always in closed condition. So three chillers has been working all the time 24/7. This is in UK, biggest fruit collection system or fruit storage system. They need to run this for 24/7, and believe me, they have come up with numbers which is talking about 70% of saving yearly in their consumption. So 70% saving yearly in UK, where the sun hours are very limited, is a big amount. Of course, it has some correlation with the power charges, that the electricity power consumption, the charges of electricity consumed in UK is much higher compared to India. So their calculation was based on that. But in addition to electricity, they have also told about the maintenance, which they have uh, obsoleted over this time. They used to change one compressor or one set of compressors for each chiller every year, which was costing them somewhere about 2,500 pounds. So now, after using this technology, the new technology, they are using one compressor every 2 years. So that $2,500 pounds has been used only once in 2 years, which was a recurring expense for them. And they are not allowed to control or close their fruit storage at any point of time. This is how it looks from another angle. If you can see from top, another beautiful example. Now here you can see that compressors, one compressor tubing has been cut and it has been closed into loop with the thermodynamic panel. And on left side, you can see a PV panel, and one side you can see your thermodynamic collection system. Okay, ambient temperatures. I'm sure that some of us are going to work in up in north conditions as well. We will be in future designing some projects for Srinagar and Leh and all other applications. So this technology works there as well. So you can see it is a -4 degrees Fahrenheit in one of the countries, and you can see the temperatures getting into a panel at -4 degrees Fahrenheit. It is 66.4 degrees C, and the temperature which is coming out is 97.2. So regardless to the ambient temperature, this technology can work as effectively as it is working in the summer conditions. All right, so some of the partner applications, what can be used with it? So all kind of process cooling plants. You can have cold storage applications. All cold storage applications can be retrofitted with it, except ammonia as on today. You can't use ammonia. All air-cooled heating or cooling chillers can be used in industries as well, where you are using a very high capacity, high heavy industrial chillers. It can be applicable to that as well. So this was it altogether from my side. We say hotter it gets, more efficient it becomes. So this technology is available in India, and in future you will see that in Delhi also we are running out of water these days, and everybody would like to switch to an air-cooled air conditioning system. What we are not able to do today is because of its less efficient technology in air-cooled without thermodynamic system. We are forced to go with water-cooled applications. So moment we have some solutions, I think we can convert this particular water-cooled application to air-cooled applications with the similar efficiency which we used to get on the water-cooled applications. So thank you very much. I'll go back to Professor Vibhuti for more interaction and question answer session. If there is any question, I would like to address that, or you can send it to me on my email addresses, and I can share that on email to all of you. All right. So any questions so far?
Any questions so far? Guys, you can speak up also if you want to.
Yeah. Anybody.
Yeah, it would be really nice to cater to all your questions. Okay.
Okay, I don't see any question into
Yeah.
the panel. So either I was too confusing or I was too clear. So I don't know. But
No, sir.
it's good
Personally,
interacting. Yeah,
yeah, it was indeed a very wonderful session. And thank you, Gaurav sir, and to all of our participants also for being there in today's special event. And it is it is wonderful to have a wonderful audience which makes up the event more successful. And I would request you guys that if you have any questions or queries, sir have given his email id and his mobile number as well,
yeah.
so you can mail him. I guess he will
You
be
can
more than
call
happy
him.
to cater to your doubts.
Yeah, sure. Shweta ma'am, we have any questions at your end?
Shweta ma'am.
हाँ जी मैम. Yes.
Ji.
I said any question at your end, ma'am? You have seen this. So I hope was to your expectation. There was some good information for you to take back.
Definitely, sir. Especially in Rajasthan, this solar hybrid energy really means a lot for us. And with the
Absolutely,
state
ma'am.
working
Yeah.
into this direction and government subsidies being helpful, we at VGU would definitely want to take this up further. And I would request your personal time and intervention for this further also in
Sure,
developing
ma'am.
this
We'll do
R&D
that. Yeah.
and taking this up professionally at VGU.
Sure, ma'am. We'll do that.
I request your association for a little longer time with us, not just for this presentation.
Sure, ma'am. We'll do that. Certainly.
Ji.
All right.
So
Thank you so
thanks
much.
for such an enlightening work, sir. Some of my faculties are also here, and I've requested a recording of this so that you can take a faculty development program also on this, where the faculties
Sure.
can more, vigilant and enriched about the topic, and we can take it further as R&D also at the university. Because being in
Sure, ma'am.
Rajasthan, we would like to take it up into more details in the architecture and the civil departments.
Sure, man. They'll be very useful for any western side of application. Even in north, it is very viable. If I speak about except Delhi, Delhi have a very smoggy days in winter, so it doesn't work at that time. But in summer season, it is very effective, even for heating into northeast and above areas like Jammu Kashmir, Srinagar, and all that. It's very effective. Certainly, you have a very good sun hours in Rajasthan, so it's very useful there. And
So
air
it's
conditioning
identified
is
as a state with
very,
the highest capacity for solar energy. So this is
yeah,
definitely an
yeah.
area where
So
we
it
would
can
want
be
to take up more works.
sure. We'll do that, ma'am. Thank you, Yachendra, for giving me this opportunity to speak to a wonderful audience today. And uh,
Thank you, sir,
no, it's my pleasure.
taking
It's my
time to be
pleasure.
here.
No, it's my pleasure. Thank you so much. Again, if you have anything, you can share my email ID with everyone and they can write it back to me if they have any questions in
Right.
this area.
Noted. Yeah.
Sure, sir.
Yeah. Okay, with this, we now need to end this session.
Thank you, Yatendra. Thank you, everyone.
Okay.
Have a wonderful day ahead. Take care.
Thank you, Yatendra sir, for actually engaging the institute with your NGO and letting us be a core person in your wonderful session which you have actually started. So all the very best for future as well, and we would like to be associated with you in more upcoming sessions.
Yeah.
And thank you so much.
Yeah.
Thank
Thank
you.
you.
Thank
Bye.
you, everyone. Bye-bye.
Bye.